Hello everyone, welcome to this new video. I am Dr. Partha Pratim Shom, working as an assistant professor in SR University Warangal. This video is going to be about Coulomb's law. Coulomb's law is a very important topic in engineering curriculum, and it is a part of the subject engineering electromagnetics or electromagnetic waves and transmission line. And this topic it basically forms the very first concept or very basic concept of this subject, so that's why I'm going to discuss about this topic in this video. Another motivation regarding motivation for choosing this topic was, or for making this video was, that like in engineering classes what I have observed is that students most of the time they understand the concepts or understand the topic very well, but when it comes to the point of implementation or for solving problems, they face a lot of issues. So that's why I am making this series of videos where I'll be talking on different topics or important topics of electromagnetics and how to use those concepts for solving numerical problems. So let us start discussing about Coulomb's law. Now, Coulomb's law basically talks about that if there is a charge Q1, sorry, if there is a charge Q1, and let me mention specifically that this charge is a point charge nature, and there is another charge Q2 which is again a point charge, then Q1 will exert certain amount of force on Q2, and similarly Q2 will also exert certain amount of force on Q1. Now this nature of force can be attractive or repulsive based on the polarity of Q1 and Q2. Now, what Coulomb did is he basically provided us a mathematical formula through which we can calculate the amount of force that is acting between these two charges Q1 and Q2. So let us try to see what that mathematical formula is. So the formula is that force on Q2 due to Q1, which can be represented or can be calculated as F21 equals to 1 by 4 pi epsilon naught Q1 into Q2 divided by R square into AR cap. Now what does these terms means? So first is that we have to understand that this force is not a scalar quantity, but it is a vector quantity, and that's why we are using this vector notation on top of F21. Okay, the next things that we have to be alert about, that this force is proportional to multiplication of the charges Q1 and Q2. Okay, and it is also proportional, inversely proportional to the square of the distance between R square. What is R? R is nothing but it is the distance between the charge Q1 and Q2. Yeah, here is the distance between the charge Q1 and Q2. And AR cap is the unit vector in the direction from Q1 to Q2. Okay, now we'll come to this term epsilon naught. What is epsilon naught? It is basically a constant, and it is called relative permittivity of free space. And it has a value of 8.854 into 10 to the power minus 12 farad per meter. Okay, some people also represent Coulomb's law in this way: F21 vector equals to K into Q1 Q2 divided by R square into AR cap, where K is nothing but it is a constant, and it is equals to 9 into 10 to the power 9 meter per farad. Okay. uh, Apart from that, we also need to be careful that this force is basically it is a vector quantity, and it has direction, and it has a specific meaning. So this, as you can see, I have written F21. It is not randomly written any term. It has a specific meaning. F21 basically represents force on 2 due to 1. Okay, if I want to represent force on q2 due to q1, and if I want to symbolize using f12, then it conveys a wrong meaning. Okay, f12 has a different meaning, f21 has a different meaning. So which term or which notation we are using, we should be very clear about their representation and their meaning. So f21 represents force on q2 due to q1. Similarly, force on q1 due to q2 will be f12. Okay, and again it will be a vector quantity. So f12 is nothing but it will be your k. I am using in this case k, which is nothing but multiplication of q1 into q2, or I can simply write q2 into q1 also, because these two are scalar quantities, and their product, like whether I am writing is as q1 and q2 or q2 into q1, it doesn't makes any difference, divided by r square into ar cap. Now this, it is this ar cap or unit vector which plays a crucial role in differentiating f21 and f12. Now what is this unit vector? uh, in case of f21, this unit vector ar cap represent r21 vector divided by r21 mod. Okay, unit vector, we all know that any unit vector, for example a cap, is nothing but it is a vector divided by magnitude of a vector. So here we have represented that same thing, ar cap, because we are talking in terms of distance, r21 or r. So this ar cap is nothing but it is r21 vector divided by mod r21. Similarly, for f12, the air vector will be nothing but it is r12 vector divided by mod r12 vector. Okay, so now we should be clear about how to calculate this r21 vector or r12 vector. R21 vector is nothing but it is usually calculated as r1 vector minus r2 vector, and r12 vector, it is calculated as r21 vector minus r1 vector, where your r1 vector is nothing but position vector of charge q1, and r2 vector is nothing but position vector of charge q2. Okay, so while solving numerical problems, we need to be very clear about using the correct distance vector, and also to identify the position vectors correctly. Otherwise the problems that we will be solving, that will give us a wrong answer. One more thing that I would like to add here is that uh, this Coulomb's law, it can also be represented in this way, that for example your f12 vector can also be written as, or I can simply say f vector. This can also be written as k into q1 into q2, and this AR cap or the unit vector, it can be represented as in terms of its constituent vectors r vector divided by mod r. So mod r and r square, if we multiply them, it will give you r cube. So this can also be another way of writing your Coulomb's law. Okay, here for simplicity, I have not written anything specific, but if we are talking about f12, it will be, this distance will be r12, and if this distance will be r12 cube. Okay, so this is about your basic concepts on Coulomb's law. What does Coulomb's law mean, and like what does how mathematically we can represent Coulomb's law. Now let us try to solve some mathematical problems on Coulomb's law. So now let us try to solve our first example. So this first example is saying that to find force on charge Q1 which has a value of 20 microcoulomb due to another charge Q2 which has a value of minus 300 microcoulomb. The position of Q1 is at 012 meter and the position of Q2 is at 200 meter. So what we will do now first is we will write the formula of force according to Coulomb's law in two different ways. One way is in terms of unit vector and the second way is using the position vectors. So the force, I want to calculate force on charge Q1, so I am naming this force as a F12. So this F12 vector will be nothing but it will be K into Q1 into Q2 divided by R square AR cap, or F12 vector K into Q1 Q2 R vector divided by R cube. I can choose any of these two formulas for solving this numerical problem. And one point that I want to add here or want to suggest here is that if you observe here, I have not written 1 by 4 pi epsilon naught, rather I have used the constant k. The reason being is that we know the fixed value of k as 9 into 10 to the power 9 meter per farad. If we take 1 by 4 pi epsilon naught, then first we'll have to replace the value of epsilon naught, then we'll have to calculate the value. So it becomes a bit difficult. Sometimes we may do some mistakes. So to avoid that, we can directly solve this problem by using the constant k, whose value we know very well that it is equals to 9 into 10 to the power 9 meter per farad. Now, I'll give you brief idea about how to approach the problem using both these ways. So if we see both the formula, Q1 and Q2 are the first two unknown terms, and the value of Q1 and Q2 both are given in the question. What we should keep in mind is that in Coulomb law, Q1 and Q2 both should be taken in coulombs. The unit of charge should be in coulomb. But here if you see in our question, Q1 is given as 20 microcoulomb. So that means we have to convert it into coulomb, which is nothing but 20 into 10 to the power minus 6 coulomb. Likewise, Q2 is given as minus 300 microcoulomb. So Q2 will also get changed to minus 300 into 10 to the power minus 6 coulomb. Then only we will replace these values in the formula. We will not replace directly 20 and 300 because that will be wrong way to solve this problem. As I have said that Q1 and Q2 they should be taken in coulomb. Similarly, the value of R should be taken in meter. Okay, if these coordinate points are given in a different unit, then we'll have to convert these coordinate points first into meter, and then we'll have to replace them in the question. For example, in some question it is given as 0, 1, 2 centimeter, then we should be converting it into 0, then 0.01 and 0.02 meter, and then only we should be using these values for calculating distance or unit vector, whatever. Okay, so this is the important points that we should keep in mind while solving this problem. Now our task is to calculate the unit vector. uh, so this unit vector, as you know, that it is nothing but it is r vector divided by mod r. Okay, so if we calculate more r vector, then we can simply use in this formula, in this second formula, and we can find our answer of force directly. So what I'll do is I'll use this second formula only for solving this question. So first is now how to calculate this r vector. So I'll give you a kind of, you can say, trick or short approach to calculate this r vector correctly. So you should remember it in this way, that r vector is nothing but it is the subtraction of destination point minus source point. Okay, so this is nothing but destination point minus source point. Now what do I mean by destination point and source point? So it means that at which point I want to calculate my force. I want to calculate my force on Q1, which is located at 0, 1, 2. Okay, so what I'll do is I'll first write the coordinate of 0, 1, 2. Okay, minus I want to calculate the force due to charge Q2. So Q2 I'll consider as the source and Q1 I'll consider as the destination. I hope it is clear to all of you how I am saying or how I am differentiating destination and source. Practically, there is no such thing exists called destination and source. I'm just using these terms for solving the problem in a easier way. So what we will do while calculating r vector is that first we will identify the destination point. Destination point means the point at which we want to calculate the force, and minus source point is the point because of which we want to calculate the force. Okay, so in our case we want to calculate force on Q1, and where Q1 is located, Q1 is located at 0, 1, 2. So my destination point will be nothing but 0, 1, 2, and the force is applied by which one? It is applied by Q2. So that Q2 will be the source point, and where is Q2 is located? Q2 is located as 2, 0, 0. So by subtracting this I will get r vector. Now it will be minus 2ax cap plus 1ay cap plus 2az cap, which, okay, so if we get r vector, then we can easily calculate mod r vector. Mod r vector will be nothing but square root of minus 2 whole square plus 1 whole square plus 2 whole square. So this will give me square root of 4 plus 1 plus 4, that means square root 9, which will be nothing but 3. So my mod r or r is nothing but it is my 3 meter. Okay, so if we look at this formula, now we have the value of k, we have the value of q1, we have the value of q2, we know what is mod what is r vector, and we know r or mod r, so we can easily calculate rq. Now we'll try to replace all the values that we got in the final expression, and we'll try to calculate the final value of force. So what was our expression? Our expression was F12 vector is equals to K Q1 Q2 into R vector divided by RQ. as we decided that we are going to use this formula of Coulomb's law in terms of distance vectors. So hence we have written this. Now what is k? We all know that k is nothing but it is 9 into 10 to the power 9. Then what is q1? Q1 is nothing but it is 20 into 10 to the power minus 6. Let me remind you all again that q1 was given in terms of microcoulomb. So it is very essential that we convert it into in terms of coulomb first and then use it in the equation. Then multiplied by minus 300 into 10 to the power minus 6 again, multiplied by r vector, which was nothing but minus 2ax cap plus ay cap plus 2az cap. This whole thing will be multiplied by 3 cube, or you can directly write it as 27. Okay, then if we do little bit of simplification, after that we can get our final expression as 6 into 2ax minus ay minus az whole divided by 3, and the unit of force, as all of you know, that it is equals to Newton. Okay, so I have not shown the detailed step or detailed calculation between the line number 2 and line number 3. I have just simply replaced the final term or final line. You can calculate all these things by yourselves and you can verify at your on your own. So finally F12 can be said to be as 4ax cap minus 2ay cap minus 2az cap. So this will be the final value of the force on Q1 due to Q2. Okay, so I hope you have understood this first numerical example and how to use Coulomb's law for solving this kind of situations or this kind of problems. Now we will move to question number 2. So the question number 2 is saying that there is there are 2 point charges of 1 microcoulomb and the second one is of 22 microcoulomb. These point charges are located at 3, 2, minus 1 and minus 1, minus 1, 4. Calculate the electric force on a 10 nanocoulomb charge located at 0, 3, 1. So again, I'll first write the formula. My formula is F equals to K Q1 Q2 divided by R vector and multiplied by r vector and divided by r cube. Now we have to understand two things, that here in the previous problem or previous example the number of charges were 2. There was one charge q1 and there was another charge q2, and our task was to calculate force on q1 due to q2. But here in this problem we have a system of 3 charges, q1, q2 and q3. Okay, and the question is asking net force on, suppose let us say q1 is nothing but 1 microcoulomb, q2 is 22 microcoulomb and q3 is 10 nanocoulomb. So the question is asking me to calculate force on q3 due to these charges, both these charges q1 and q2. Okay, so before solving this problem we have to know one concept, is that Coulomb's force, it follows superposition principle. So force on 3 will be equals to force on 3 due to charge 1 plus force on 3 due to charge 2. So total force on charge Q3, that is F3 is nothing but it is vector sum of F31 plus F32. So if we calculate F31, our like task will be, or our objective will be to calculate this F31 and F32 separately, and once we calculate them, then we will replace them in the final value to get our in our final expression to get our final value. So again, for this problem also I will not tell you I'll not show you that in between steps or solving steps in detail. What I'll do is I'll just give you an idea how to replace the values in this equation of force, and then what final answer you will get or you are expected to get, so that you can verify the answers at your own, at when you will be watching this video and solving this problem. Okay, and you can do one thing, whenever you will be solving this kind of problems, you can pause this video in between wherever needed, and then you can solve this question on your own, and after that you again resume playing this video and just verify whether the answer that you have got is matching with your answer or not. Okay, so first to calculate F31, just first let me write the formula for F31. So F31 will be nothing but K Q1 Q3 into R13, or sorry, yeah, so it will be R31 divided by R Q. Okay, so as you can see, initially I wrote R13, but then I have changed it to R31 because writing the correct values and using the correct formulas is very important, especially when you handle vector directions. Okay, so now R31, as I have told you about the trick or process, that it is nothing but it will be destination point minus source point. So what is my destination point? My destination point is 0, 3, 1, because I want to calculate force on 10 nanocoulomb charge. So my destination point is nothing but it is your 0, 3, 1. So I'll write that 0, 3, 1 minus, what is source point? Source point is we are calculating force due to this charge Q1. So the Q1 is located at 3, 2, minus 1. 3, 2, minus 1. So we'll subtract them, and finally what we'll get, R31 will get as minus 3ax cap, then plus 1ay cap, and plus 2az cap. So this will be my R31. Similarly, I can also calculate R32. R32 vector will be nothing but first destination point as usual 0, 3, 1 minus the source point. Source point here for Q2 is minus 1, 4. So I'll replace that minus 1, minus 1 and 4. So this will give me 1 ax cap plus 4 ay cap and minus 3 az cap. So this will be my R32 vector. Okay, so let me also calculate simultaneously mod R31. Mod R31 will be nothing but square root of 3 square, that means 9, plus 1 plus 4. So it will be square root 14. Similarly here R32, the modulus of that will be equals to square root of 1 square plus 4 square plus okay, minus 3 whole square. So this will be 1, 4 square 16, and 3 square 9. So 16, 9, 25, square root 26. So this will be my value of R32. So once we have got these values, just so now as we did in previous problem also, we'll replace the values in the final expression. So first is my F31, which is nothing but K, that means 9 into 10 to the power 9, and value of Q1, which is 1 microcoulomb. So I will replace it with 1 into 10 to the power minus 3, and Q3 as it was given in the question as 10 nanocoulomb. So 10 into 10 to the power minus 9. Okay, so value of q1 and q2 are replaced, and then it will be multiplied by your r vector, or to be specific r31 vector, which is nothing but your minus 3ax cap plus 1 into ay cap and plus 2 into az cap. So this whole thing will be divided by square root of 14 cube, or in other words you can write it as 14 square root 14. You can use any of these values for F31. Similarly, F32 will be nothing but 9 into 10 to the power 9 multiplied by the second charge was of minus 2 microcoulomb, so I'll write it as minus 2 into 10 to the power minus 3. Then it will be that Q3 charge whose value was 10 nanocoulomb. So I'll again write 10 into 10 to the power minus 9 and multiplied by R32 vector, which we have obtained as your 1ax cap plus 4ay cap and minus 3az cap. So this whole thing will be divided by root 26 cube, or I can write it as root 26 into root 26. Okay, so this is we'll get two force values F31 and F32 after replacing them in the Coulomb's law formula, and once we solve this, finally we'll get F vector as F31 vector plus F32 vector. So after adding both these quantities, we will get final answer as minus 6.5 ax cap. Some student may get the final value as minus 6.4, minus 6.3, depending on how many points they have considered after the decimal point. So this much deviation, this much variation is acceptable enough. So minus 6.5 ax cap, minus 3.7 ay cap, and then plus 7.5 az cap millinewton. This will be your final value of force. Okay, so just to give you a quick overview, we'll have solved two numericals related to Coulomb's law. In the first numerical, the conditions was that we have a charge Q1 and we have another charge Q2, and we were supposed to calculate force on Q1 due to Q2. Then in the second problem, we have extended the system into a system of three charges. Okay, and we were supposed to calculate force on this third one, or like we can call it as F3 vector. So whenever there will be system of multiple charges and it is asked to calculate the force on this single one, so there may be two charges, there may be three charges, there may be four charges, but the force on this one will be nothing but sum of these individual forces, because Coulomb's force follows superposition principle. So it doesn't matter whether the like we want to calculate force on this one due to two charges or due to three charges or due to n number of charges. Force on this one will be sum of all individual charges. So this is all about Coulomb's law and solving problems involving Coulomb's law. We'll meet again in one new video covering a topic related to covering a new topic related to electromagnetics. Thank you for watching this video.